Hey everybody, just wanted to welcome you to Module 6, Week 6 for ME12 Dynamics class. So this week we're taking a look at the kinetics of a particle, in particular some impulse and momentum problems. So we'll take a look at conservative forces and energy from the end of Chapter 14. So we're going to do a brief review and cover a 5.3 module at the beginning of this, and then we're going to begin looking at the principle of impulse and momentum as we move into Chapter 16. So by the end of this module, we'll have a couple of goals here. We want to be able to develop the principle of linear impulse and momentum of a particle and apply it to solve problems that involve force, velocity, and time. We're going to take a look at the study of conservation of linear momentum of particles, analyze the impacts of the mechanics of impact, introduce the concepts of angular impulse and momentum, and solve problems involving steady fluid streams and propulsion of variable mass. Reading requirements for this section: read through Chapter 15, Section 1, and Chapter 15, Sections 2 and 3. Only assignment this week, no homeworks, just a reading quiz. It'll be due on Friday the 9th by 4 p.m. So as I mentioned, we're going to begin this module by doing a refresh of the end of the last chapter. So we're going to call this Lecture 5.3 from the end of Module 5. We're going to look at conservative forces and potential energy and conservation of energy. Objective is to understand the concept of conservative forces and determine the potential energy of such forces, and apply the principle of conservation of energy. We'll go through a couple applications, look at conservative forces, potential energy, conservation of energy, and do a couple problems involving these. So let's move on to Module 6.1 now. We'll take a look at the principle of linear impulse and momentum. Objectives for this section: we calculate the linear momentum of a particle and the linear impulse of a force, apply the principle of linear impulse and momentum, taking a look at different applications for linear momentum and impulse, and the principle of linear momentum and impulse, and how do we apply this to problems that we're going to solve. So when we talk about the principle of linear impulse and momentum, so the principle of linear impulse and momentum in vector form is written as the following down here. So we have our mv1 plus the summation, the integral from t1 to t2 of our force F dt is equal to mv2. So the particle's initial momentum plus the sum of all the impulses applied from t1 to t2 is equal to the particle's final momentum. So that's a way of verbalizing this equation that we have right here. So the two momentum diagrams indicate direction and magnitude of the particle's initial and final momentum, which is our mv1 and our mv2. Whereas now our impulse diagram is similar to a free body diagram, but also includes the time duration of the forces acting on the particle. So if we break this down a little bit and talk about the principle of linear impulse and momentum, we start with Newton's second law here. We have summation of forces equal to mass times acceleration. We recall that acceleration is the first time derivative of velocity, or our dv dt. So we can plug that in for our acceleration there. So now we have, if we rearrange this and put our dt here over on the other side of the equation, we have summation of forces dt is equal to mass times dv. So we can take and we can integrate both sides now of this equation. We have the summation from t1 to t2 of our F dt is equal to our mass, that's a constant, so we can pull it out front there, integral from v1 to v2 of dv. Well, we can do out that integral right there, so we leave the left alone for now and say the summation of the integral from t1 to t2 of F dt is equal to our mv2 minus mv1, which is when we take this integral here and apply our limits of integration. So then we can move this over now and put this in vector form and take this m1 v1, add it back over here to the other side. So we end up with this equation here, m1 v1 plus the summation from the integral from t1 to t2 of f dt is equal to our m2 v2. Now in this case here, our m1 is equal to m2, which is just called m. So this is how we come up with that principle of linear impulse and momentum, starting with, right there, Newton's second law. So then we'll move on to the next section. We're going to call this lecture 6-2 here for module 6.2. So this is the principle of linear impulse momentum. So we're going to learn how to apply this principle to a system of particles and understand the conditions and for conservation of momentum. Activities: go through this linear impulse and momentum for system of particles, conservation of linear momentum, and go through some problem solving utilizing these.